Okay, cool. So again, hello to each of you guys, and I hope that you are doing great. In our tonight class, I'm going to talk a little bit about functions and also file handling in Python. In the previous sessions, we learned so many things about the very basic Python syntax. We learned about how to work with conditionals like if, else, and etc. We learned how to work with loops, and we work with for and while. We saw how we are able to create loops for repetitive tasks in Python, which is very, very handy and very useful. Again, in our tonight class, we will work on a couple of more examples to see how it works in reality. For example, how we are able to use Python, for example, to go and scan a wide and giant network. Imagine, for example, in a business, like in a university, in a hospital, in a bank, for example, like ANZ Bank. Imagine they want to go and test like over hundreds of multiple endpoints in a network. So obviously doing that task, hi Mahmoud, it's not easy if you want to do it manually. It takes time and also it increases the chance of having or getting errors. So highly useful and handy if you are able to automate tasks with using loops. In the previous sessions, we learned how to work with for and while, and also we just went a couple of very basic examples to see how a loop may work. In our tonight class, I give you a bit of more examples on how we are using loop in reality. For example, when we want to test hundreds of endpoints in a network, when we want to go and run and test, for example, hundreds of ports in a network, checking protocols, sending packets, and all of those things that just with a couple of lines of commands in Python, we are able to perform huge tasks. Also, as discussed, it's very important to be able to upload files in Python. Imagine, for example, again, you are working in network or ITA maintenance in a big business. For example, you have a job in IT, in NAB Bank or ANZ Bank, and what you need to do, imagine there are, let's just say 400, 500 branches. In each brand, there are 10, 20, 30, 40 different devices, including IoT devices, printers, servers, computers. So every day they generate so many logs. Each log is just like an event. From the time that one of the staff logins to a PC, it generates a log. When they open a file, it generates a log. When they close a file, edit it, change it. When they put some data in a database, it generates a log. So all of those things, even there might be some logs happening in the background that you are not aware, but it's being generated and captured by those devices. So imagine for such a big network, like in a bank with hundreds of branches, with hundreds of staffs and customers, it's very important to keep an eye on all of those logs. Sometimes there might be a suspicious activity somewhere. So if you want to go and analyze all of those logs, that there might be millions, for example, in a usual PC in a bank, every day there might be 10, 20, 30, 40K of logs, different events happen in that PC. Even a fail attempt generate a log. For example, imagine you try to log into your account and you forgot your password, or you forgot to, for example, change your keyboard to uppercase or lowercase or something. You can't log in, but still it generates a log. So a log is just like having a CCTV camera in your network which captures any movement. So if you want to go and analyze thousands of logs in each device, it's impossible. It takes time and sometimes it's impossible to analyze billions of logs. Okay, so is there any way that we can use Python for that purposes? The answer is yes. So when you go, for example, to your servers or your computers, you can download all the logs in a CSV format. CSV is pretty similar to Excel. So you can open a CSV file in an Excel sheet. Okay, even if you are able to open it in an Excel sheet, still it's not easy to analyze that load of data. But we will see how we are able to import a .csv file or a txt file. Sometimes you have text. You want to analyze text to see if there's any anomaly, see if there might be any pattern. Pattern means, for example, in NAB Bank, ANZ Bank, for majority of companies, organizations, it's very common that they have their staff starting their job from 9 o'clock or 8:30 in the morning, and probably they finish by 5, 5:30, or let's say 6 every day. It's a pretty common pattern for majority of companies. So if you see that, for example, someone logged in a system, let's say after midnight, 1 o'clock after midnight, 2 o'clock after midnight, and then they try to download a 10 gigabyte or 5 gigabyte file. So it's something unusual. And With help of Python, we are able to find if there is any anomaly in the packets, if there is any anomaly in the user behavior. Imagine you're using PayPal. So you are here in Australia and when you want to pay for some things, you use your PayPal. Sometimes it happens that you may have a VPN on your devices. And when you turn on your VPN, VPN obviously changed your IP. So PayPal thinks that you moved to another location, to another country, and then they stops all of your transactions because they suspect that it might be malicious activity or something. Sometimes imagine you go to another country, PayPal automatically detects that you are not in the previous location. You've been in Australia in the morning, now it shows that you are in US. So you are still here in Australia, but you use a VPN. Or sometimes, for example, you do a transaction which is not usual. For example, imagine I always pay with PayPal and all of my transactions are like 400 bucks, 500 bucks, 50 bucks, 60 bucks. All of a sudden, I have a $20,000 transaction, which is not usual. How PayPal is able to detect it? Imagine you purchased a car, you purchased a second-hand Toyota Corolla, and you want to pay $20,000 to the seller. So when you pay for that, you see that your bank, tips of the time, if it's your first time, they stop and they put that transactions on pending. It's possible that you get a phone call from a bank and they want to confirm if it was you and why you are paying $20,000 for something, just to make sure that you are aware and just to make sure that it was you requested for that transaction. How is it possible? When, for example, you see NAB Bank or ANZ Bank, they have millions of customers and every day they have thousands of transactions, how they can quickly go and find those anomalies. So possible by using AI, it's possible by using data analysis. And in order to do that, we need to use Python for data analysis. Python is a great tool when you want to analyze heaps of data. But firstly, you need to be able to upload your file in Python. For example, in Google Cloud, so far we just learned how to use some basic tools. But imagine you want to upload a file in Google Colab and read it. A file containing logs, transactions, locations, all of those things. So we will work with file handling as well. But before learning about file handling, firstly, let's do recap on what we had in the previous session. Let me share my screen. In the previous sessions, as discussed, we've been talking and learning about how to use repetitive tasks in Python using for and void. As discussed, we are using for when we know how many times we want to repeat something, and we are using void when we don't know how many times exactly we want to repeat a task. But when we are using while, we keep going, we keep repeating a task until a condition is true. You know that when you are using for or while, doesn't matter which one, it has a syntax. The syntax is at the end of the for or while statement or expression, you need to use colon. We need to use indentation. Obviously, if you're using IDs, when you press enter, automatically it goes to the next line and it gives you one space of indentation. Um, as you see, this is the common structure when we are using for I in range. In a range, we had a couple of practices in the previous session. You can define a range from the beginning and to the end of the range. It means that defining the first or defining the start of the range and closing of the range. Or if you just leave it open, or if you don't specify the beginning of the range, it automatically assumes that it will start from 0. Also, as you see in the previous session, I was able to increase the incrementals as well. So technically, when you create a range, it's a start from 0, then it goes to 1, 2, 3, 4, 5, 6, and etc. But you are able to change that increments from 1 to 2, 3, or anything else. So we had a couple of examples using uh, changing the incrementals. While when you don't know how many times you want to repeat something, so we can use while. We also saw that there might be cases that Python keeps repeating a task. It goes forever. Sometimes we may need to stop that process. Interruptions of loop iteration, stopping a process. So you may use break and you may use continue. The difference between these two, if you remember, break was killing the whole process. So imagine that you have 5 lines of code. The first 3 lines of code is a loop. The first 3 lines of code is a loop, and then line 4 and line 5, there is something different. So Python stays in the loop forever, or if you stop it. Otherwise, it just keeps going to the loop. It doesn't go to line 4 and 5 to execute them. It just keeps staying in the loop and repeating all the tasks that you define. Sometimes it happens that you want to stop a process. For example, in the previous session, you see that we created a code to, for example, allow a user to only try 3 times to log into their accounts. So what if the user in the first go, they put a right username and password? So technically they don't need to use the second and the third attempts. So you need to stop the process. So I have 3 attempts. If in the first and the second time I put the wrong credentials, still I may have another go. But what if I put the right credentials in the first step? So technically you don't need to go to the second and the third round because in the first go the credentials was correct. So we used break, and break was using to terminate the whole process. Sometimes it happens that you want to skip only one round of iteration. So in that case, we can use continue. It terminates the current loop. It doesn't terminate the whole process. And we saw an example of continue as well. Let's go back to our Google Colab. So let me to stop sharing this and let me to reshare my screen. Okay. Google Colab. Let me reshare my screen. Okay. So let's work with a couple of more practices to be confident working with loops. And then I go to function. We will see what is a function and how we are able to use functions. Let me delete this as well. Okay. Okay, so in the previous class, we worked with a couple of different examples using void and for. Let's find another activity to see how we are able to use loop. Let me find a good cybersecurity example for you. Hmm, Cybersecurity example. Okay, so this is another good example. I name it password strengths checker. Obviously, you've been in situations that you've been pushed and you've been forced to change your password strengths. When we are talking about password strengths, it means increasing the length of the password. Not only that, it means that using a combination of lowercase, uppercase, symbols, and etc. Later on in set 4 in cybersecurity, if you go to set 4, you will see this password complexity. Let me show you an interesting chart. Password complexity matrix. So this is a good example. As discussed later on, when you go to set for in cybersecurity, we will see why increasing the length or mixing the password using uppercase, lowercase, symbols, and etc. Uh, can make it harder. I don't want to say it's make it impossible for the attackers to guess your password, but it make it harder. It takes more time. Here you see in the left, let me make this a little bit bigger. You see that in the left column, I have number of characters, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The second column, it shows numbers only. It means if you have a 4-digit password, which contains only numbers, attackers are able to detect it instantly. I would say in a second. It doesn't matter even if you increase the length of the password to 5, 6, 7, 8, 9, and 10 instantly. So now there are some password crackers that they are able to check and guess billions of passwords in a second. Anyway, if you increase the length of password to 11 character, only numbers, imagine that it's only numbers. It can take the attackers only 2 seconds. Increasing to 12 character, 25 seconds. If you have a password with 18 characters, but only numbers, it can take 9 months to detect it. I would say this data form is for a long time ago. And even if you have a password with 18 characters, only numbers, it can take probably 1 week or 2 weeks for the attackers to guess it. But if you just compare this second column to the other column, like using lowercase letters, upper and lowercase letters, using numbers, upper and lowercase letters, and using numbers, upper and lowercase letters plus symbol, you see that it significantly change and increase the time for the attackers to guess your password. It means if you have an 8 character password, only numbers, in a second, attackers are able to guess. But if you have 8 character password, but it's a combination of uppercase, lowercase, symbols and letter, it takes 8 hours. So if you have a pretty long password, let's just say 12 character, with all of those uppercase, lowercase, symbols and numbers, it takes probably 34,000 years, which is a long time, quite long time for the attackers. As discussed nowadays with improvement in AI and improvements in processing power, these numbers are much less than those we can see in the table. So it means that even if you have a 12 character password, it shouldn't be 34,000 years, but it should be quite long for an attacker to guess and detect it. Nowadays also, probably you heard about passphrases. Passphrases are a combination of multiple words. Instead of just using your a word or a combination of a word and a number and symbols, it might be an string of multiple words, passphrases. And also, obviously, we are using multi-factor authenticators, which is a very, very good cybersecurity technology. But just imagine this table, and we want to write a code for password strength checking. So let me go back, and I want to do this with the help of for loop. So imagine, I know that we still didn't touch the list, tuple, and dictionary, but just to show you, imagine I create passwords as a variable. And then in my password, I can have admin, very common password. There are so many IoT devices that they have a username of admin and password of admin or 1234. It's very common for so many IoT devices. Now they are changing, but still there might be so many IoT devices with the password admin or password as you see, 123456 as you see. They are very common passwords. So we can create a loop like this for, again, you can use I, or in this case, I use PWD just to show you that you can use PWD as well instead of I or any other letter or any other words. Doesn't matter. For PWD, it means that for any item in passwords, it means that for each of these 3 items in this list, for PWD in passwords, what to do when I press enter, it automatically goes to the next line, and then it has an indentation as well. If the length of the password, so again, that's another command that you can use when you want to see and you want to check the length of a word. Len, L-E-N, this stands for length, PWD is less than, let's say, 8 character. So you see that now I have 2 indentation, one indentation for the for and the other one for the if. I'm not asking you to write this code because still there are a couple of things like lens that we didn't learn about it. I just want to show you how it works and just do a refreshing on the logic of using for and if. If the length is less than 8 character, then print what? Print PWD. So just print it and then type it's a very weak password. It's a weak password. Or this password doesn't meet the requirements. That's the message that you usually get when you put a pretty weak password. You can say this password doesn't meet the requirement. Doesn't meet the complexity or password requirements. Please change it. Something like that. Or sometimes you try to log in, it says that you already used this password. So please go and generate another password. Sometimes when you try to create a password, it tells you that the password cannot be a combination of your name. So for example, imagine Connor wants to set a password and he says Connor 12345 6 somethings, or Connor another number. It says sorry, you are not allowed to use that password because it includes your name. So all of those things, they have the same logic. So in this case, it says if the length is less than 8 characters, just print it and say this password doesn't meet the requirements. The code should work. I don't need to define the elif or else. Okay, it should work. You can see, I can run it. Admin, this password doesn't meet the requirements. And 1, 2, 3, 4, 5, 6, this password also doesn't meet the requirements. So what happened here? Admin has 1, 2, 3, 4, 5 character. Password has 1, 2, 3, 4, 5, 6, 7, 8 character. And 1, 2, 3, 4, 5, 6. It has 6 character. What happens? The first step, you created a variable, then you have a loop. So the loop goes and checks each item. So if you, for example, change admin to another things, admin for the web, make it more than 8 character for the web server, and you rerun the code. So you see that it disappeared. Why? Because technically it has more than 8 character. So what happened here? There are two situations. Firstly, there is a loop. So the loop goes and checks each item in the list. Again, 1, 2, 3, 4, 5. If you add some other numbers here and you rerun the code, you see that it shows nothing because you didn't define. If you want to define that, what Python needs to do, if all of those items in the list, they meet the password requirements, they are more than 8 character, so you can define it. How else? So what happens here? You have a loop for each item. It goes and check if the length of the password is less than 8 character. It shows this password doesn't meet the requirements. If the length of password is more than 8, so Python is able to go and count. For example, here ADMINFORT, it's able to count all the letters. And if it's less than 8 character, it goes here. Is the length less than 8? If yes, if this condition is true, then go and print this. If not, so we know that Python will jump and skip and ignore this section. It goes to the next section, which is else, and it will print this password meets the requirement. Let's see. So you see that it says this password meets the requirements, password is the requirements. So just to do a recap on what we have. The other things that we can do to make it more sensible what happens in cybersecurity or how it's look like in cybersecurity. Let's do find another example. So we used login attempts limiter, reboot countdown. We work on that case as well. Port scanning. Okay, that's another good example. What are ports? Ports are like we learn about that in a networking unit that we will have it next time. We will learn about network devices and network protocols and ports. So in a simple word, port is just like radio stations. Imagine that you have a radio and you can tune your radio to multiple radio stations. For example, you can tune it to AAA, ABC News, um, Triple J, Nova 100, all of those radio stations. So they have a fixed signal. In the same way in IT, there are so many services. For example, when you are opening a website like this, ABC News, a website use two ports, like port 80, port 443 and port 80. That's the port that we use for opening websites. For example, if you're downloading a file, if you're trying to connect to a remote desktop, all of those things that we do in our computers, they need to use a specific frequency or a specific port. So another example that we can use using loops is, for example, doing a port scanning. Why it's important? Because in cybersecurity, each port or each door, it might be a vulnerability. Later on, again, you will learn about that. I'm just trying to show you some examples in reality. So I can name it port scanner. And again, pretty similar to the previous case, I have some ports and I put it again in a list like port 21. We use it for file download, port 22 for SSH remote connection. We will learn about all of this port 23, port 80. It's for HTTP website. We have port 443 for HTTPS. And there are so many. So I have these four ports and I want to, in reality, we have like 65,000 ports. So if you want to go and test and check all of those 65,000 ports, it takes time. And also when there are so many ports, it increases the possibility of getting errors or doing mistakes. Again, you can create a loop, for example, for ports, imports. Here you see that instead of using I, Google Colab suggests me to use port. If you want to change it to I, you can do that. You can say for I import, just do this. What should I do? Print this sentence, scanning port, and then the port number. So firstly, it goes and print a scanning port 21. Then in the next line, a scanning port 22, a scanning port 23, 80, 443, 3389. And then when it finishes all the numbers in the ports, it says stop. Let's see. So you see that a scanning port 21, a scanning port 22, a scanning port 23, a scanning port. Or if you wish, you can change it. For example, you can say if the port is 23, just say something like this. Instead of printing something, I can say for I imports, then go and check if. So if I is equal to 21, print it's an FTP port. If the port is 22, print its SSH port. If it's 23, just type it's a telnet port. The same for HTTP, HTTPS, RDP, and etc. Look, so it prints all the ports name. So it's correct. Port 21 is FTP, it's for file transfer protocol. For 22, correctly it says it's SSH, secure shell connection. We will learn about all of these ports. Cool. So let's do work with functions. Let me switch back to my board and have a chat about what are functions, and then we will be back to Google Colab with a couple of more examples. Let's reshare my screen. Cool. The next topic that we want to learn a little bit is talking about functions, to see what are the functions and how we are able to create a function in Python. Let me put this title down. Functions. Before talking about functions, in your assessment task 2, as I showed you in the previous sessions, we have something called pseudo code. code. Pseudocode. What is pseudocode? As I explained in the previous session, it's an structure to describe an algorithm. I show you so many examples in the last couple of sessions. For example, if tomorrow is rainy, then do this. If tomorrow is sunny, then do this. Or in the previous example for ports, go and check. If the port is 21, print FTP. If the port is not 21, then go to the next step. So just like a step-by-step instruction. So pseudocode is structured. In your assessment task 2, there is a question asking you write or explain your pseudocode for password management activity. So it's an structured English used for describing algorithm. Again, in the first session and before talking about Python, we learned about algorithm. Imagine you want to make a cake, and as we use that example, there might be multiple steps. The first step is just go and use these ingredients, then go and put it in an oven, then add this, then. So a couple of instructions which tells you how to make a cake or how to follow a recipe. The same things when we are using and when we are writing the code. The purpose of pseudocode is just to provide a way for you to specify the algorithm in your own word. So before jumping, when you've been asked to write a code in Python, before jumping to write the codes, firstly, step by step, write it down in your own language. If I want to do this task, what I need to do. We work in so many cases like currency converter, distance converter, BMI calculator, tax calculator, GST calculator, pizza shop menu. For all of those things, firstly, write it down in your own word. If I want to do this task, I need firstly to create a variable. The variable helps me to save this data. Then I have a formula. Then I need to print this. Then I need to add these three numbers. How it works, how your code should work in your own word. It doesn't need to be in Python. Firstly, write it down in your own words and then just try to see if it works. Let's say, for example, let's see if my code works with this number, if it gives me the right result and the right answer. If not, what might be the issue? Just think logically. Try with different situations, try with different numbers. And if it works, then in the next step, try to change it to Python syntax. It allows, it's very important, even for big projects when we are using Python, we need to learn this skill. Imagine I want to ask you a big project, for example, setting up an application. So firstly, what developers do, they break down the whole project into so many small pieces. It's not like that, okay, we need to set up this project, so let's go and start typing and start coding. No, they break down the whole project into so many small pieces. For example, imagine for a website has multiple options. For example, there should be a section for login. There should be a sections for adding to the cart. There should be a sections. So for each sections, the developers, they go and they write the code, they test it, they check it. And when all of those pieces, all of those sections are working, then they merge it. Then they put it together and you can see a website. But in a web page, let's say, for example, you go to Office Work website, it includes so many small sections. A section for, I don't mean about the products, the structure of the website. So it has a section for main page, it has a section for login, it has a section for reviews, it has a sections. All of those sections, they may have a different team that they go and test it and check it. They make sure that if it's working, if it's fine, if there might be any issue or bugs, they fix it. Then all the teams, they put their codes back together, they merge it, and you can see a website, an integrated web page. So it allows the program designer, it allows program designer designer to focus on. If you learn this, you can write any code. It doesn't matter if you're not fast. It doesn't matter if it's still not your vision. If you get the logic, if you get how you need to bring down all the steps in the paper and then change it to Python, you should be a good programmer. So to focus on the logic of the algorithm, logic of algorithm without the distraction of programming language. When you are typing and when you are putting down your pseudocode, just try to be precise, concise, and language independent. What does it mean? Precise means when you want to write the codes, you need just to, the writer and all subsequent readers, they need to understand exactly what is required to be done. For example, I gave you a task, write a code to calculate the average of three numbers. Okay, so firstly, I need to ask for the first number, the second number, the third number, then I need to add all of those three numbers to each other, then I need to divide it by 3, and then print. Okay, converter. Firstly, I need to ask about the amount, then I need to know the conversion rate, then I need to multiply, then to print it. So you understand exactly what is required. In the previous case, I was checking the ports. So firstly, I need to have a bunch of ports. Then I need to create a loop. The loop, it goes and check each item in the list. It compares. If it's equal to 21, then it prints the name of it. If not, it jumps to the next section. If that second section is not true, it jumps to the third sections. It should be concise. It means that there shouldn't be any unnecessary um, lines of codes. If it doesn't help you, just delete it. For password manager, some students, they ask ChatGPT to write them a code, and ChatGPT gives them 400 lines of code. So you can write the password manager using 20 to 30 line of code. When you can write the code with 30 line, why you should have 200 lines of code? Some of those lines might be unnecessary. And in those cases, usually I ask the students, okay, it seems that you use this line, you use this library. Can you explain to me why and how it helps you? I don't know, I just used it. So we need to be short, specifically when it's a big project. Even one line of code is important, because if we manage to reduce 10% of programming lines, and imagine that you have 200,000 lines of codes in an operating system, it might be million lines of codes. So reducing the lines even by 5%, 1% even, it's a lot. So it should be short and concise, just, avoiding and removing any unnecessary. And language independent, it means it doesn't matter if you're using Python, or if you're using C Sharp, or if you're using C++ or whatever, doesn't matter. If you understand the logic, then you can go and convert it to Python, and you just need to know some syntax in Python and you learn it. It's just like, I know how to drive, you know how to drive. So it doesn't matter if you have a Toyota, or if you have a Kia, or if you have a Hyundai, or if you have a BMW, doesn't matter. You know how to drive. So you can drive technically any car, but you know how to drive. That's the skill. So when you learn driving, you can drive any car. It doesn't matter if the car is 4-cylinder or 6-cylinder or 8-cylinder, doesn't matter. Yes, obviously, if you want to drive a truck, you need to have a higher qualifications or skills. But technically, when you have a full driving license, you can drive any car. It doesn't matter what brand is it. It doesn't matter model. It doesn't matter engine size. So it's language independent. It means that you understand the pseudo, you understand the logic, and then you're able to write the code. Why it's important? Because it's an introduction for functions. For example, a pseudocode in your own language, it might be something like this. Wake up, doing morning things. Morning things for someone might be doing a yoga, might be preparing the kids, I don't know. Then you have if. If it's raining, if it's rainy, then driving or using your own car. Else, it means that if it's not rainy, you can use public transport or your scooter. End. So this is a very simple pseudocode for everything, for your daily task, for cooking, for you just need to put down all of this in your own word, and then it helps you to create functions. What is functions? Firstly, let's to define it, and then I'll show you how it works, what is the syntax, and why functions are so important and useful in our coding. So a function is a set of a statement. Is a set of statements that takes input and they do some specific task. What does it mean? Imagine that, for example, in our previous sessions when we practicing using if, we created a calculator. Let me see if I can find it. Let me share my screen to go to our previous codes and find that activity. Currency conversion, temperature conversion, BMI calculator, pizza shop menu, discount calculator, temperature, ATM, car fuel, speed, score, like this one. Let's use this one. What was this task? Checking if a number is positive, if it's negative, or if it's zero. Pretty easy one. Imagine that you use this bunch of codes so many times in your codes. Multiple locations, you need to refer back to this number checker. Or for example, if you have, let me see if I find the calculator or interest rate calculator. Imagine that you write all of these codes. What it does, it calculates the interest rate for you, and it has only 1, 2, 3, 4, 5, 6 line of code. But imagine that you have a code and it has 600 line of code to perform a task. I don't know, to calculate the rate, to calculate the temperature, to perform a specific task. So if you want to use this bunch of line of code multiple times in your programming, does it mean that you need to again and again and again copy and paste all of these lines of code? Or no? Is it possible to put all of these lines in a wrap, and whenever you need it, you don't need to copy paste all of those lines again and again? You just give it a name, for example, interest rate calculator, and whenever you need it, you just say interest rate calculator. It automatically performs the task for you. It doesn't need to redo the coding. It doesn't need to copy paste all of those lines again and again. Again, in this case, I have only 6 lines, but it happens that there might be 600, 1600, thousands of lines in a bunch of codes and lines of codes, and you need to reuse it again and again. So instead of copy pasting all of those lines, it's possible in Python to put all of those lines, let's just say in a parcel, in a package, wrap it, name it, and whenever you need it, just call that package, just call that box, and Python is able to go and find it and execute your codes. That's the intention of functions. So a function is a set of a statement, a set of lines like this: principal, rate, years, interest, total, print, and etc. Then you can wrap it, you can give it a name, and when you need it, you need to call it, just like your servant. Python by itself, it has some built-in functions. Let me go back to my board. We name it Python built-in functions. So it already comes with built-in functions. Imagine you go and you purchase a new phone. When you purchase a new phone, by default, it has some applications. So when you purchase a new phone, probably it already have YouTube, probably it already have weather applications, probably it already have uh, photo or gallery applications. So it already comes with 5, 6, 10 applications. But obviously you have the option to go to App Store or Google Store and download more applications. Built-in functions, they are similar to those already installed apps. For example, print. Print is a built-in function. It means print may contain lines of codes. So you can't see those line of codes, but when you type print parentheses, it knows that it should go and show some things in the console. But in the background, print contains multiple lines of codes. You just need to say print, but for Python, in the background, when you type print, parentheses open, parentheses close, and you have something in the print, it goes and follow an algorithm, and it shows you the results in the console. So this type of functions, if, for example, if a built-in function, so when you type if and you follow the syntax, you use the colon, it knows that I should go follow all of these steps. I need to compare this, I need to check the data and the value in this variable. So it follows a bunch of actions and activities just to do that comparison for you. But also, if you want to create your own functions, you have that option. We name it user defined. User defined functions. So you created for your own. You can share it later if you wish. Imagine that you invented and you created a bunch of code that it performs a task for you. Then you can share it with others. They can use it for free as well. In Python, there are so many user-defined functions that they are already freely available for different purposes, for data analysis, for cybersecurity. It means that all of those codes, they already are generated and tested with someone else, and now they are freely available for you to use. So you don't need to go and reinvent the wheel. It's already created. It doesn't mean that you need to start from scratch. For anything, for data visualization, there are so many functions already available. You just need to go and call it and import it and then use it. Some of those functions are so in detail and comprehensive, we name it libraries. So if I go back again to my browser and show you, you can simply go and type Python libraries. You see there's so many libraries. Python library for AI, for data visualizations, for data analysis, for machine learning, for data science. If you simply type Python libraries, it says Python libraries are collections of pre-written code or modules. So here in Google Colab, each of these sections is a module. So one module for BMI calculator, one for age converter, one for pizza menu. It says each library, it's like a pre-written code or modules that they offer some functions, classes, and resources to simplify and accelerate development in various domains. It means they already are available. You don't need to go and reinvent the wheel. You just need to use it, and it's free because Python is free. Python is an open source. It means that you don't need to pay for the license or registration. It's free. And all of those functions are already generated by someone else and it's available for you. For example, you see some of the very, very most important libraries like NumPy. It's the fundamental for numerical computing, providing support for multi-dimensional arrays and mathematical functions. We don't use libraries in this set 3, but they are available. Pandas is essential for data manipulation. Matplotlib, it's a very, very useful library if you want to visualize your data, creating charts and graphs and etc. So you don't need to go and write all the codes to visualize your data. The only things that you need to do just to import matplotlib or Seaborn or scikit-learn or PyTorch. So many, there are so many. The Django, for example, for web developers. Still, it's in the platform of Python, but there might be some codes already generated. They perform some specific task for you. If you are a web developer, you can go and use the Django or Flask for web frameworks, building web applications. Flask is lightweight. The Django is full stack framework for larger projects. You just need to import it. How? You just need to go here, open a new block or a new module, and you just need to type import pandas, for example, or numpy. You see that it's automatically detected. Import pandas as pd, and then a bunch of codes, might be hundreds, thousands lines of codes, is already included in pandas. So when you import that, it's just like installing an application in your phone that now you can use it for, I don't know, video streaming, gaming. So when you download and install a game, that game already has a million lines of code. You just go download it from App Store, you install it, then your iPhone or your Samsung device or your Android device is able to go and read those lines of codes and execute it. I reckon I may have some of those. Uh, if I can find it. For example, you see here, import matplotlib. So I imported it. It's for another class. It's not for certificate 3. And what it does, it performs so many things for you. For example, it creates a chart like this. So it can help you to create charts, graphs, data analyzing, and so many other things. I reckon I have a couple of examples just to show you how it's look like. For again, for data sets, for machine learning, for AI, there are so many. You just need to go and import it, and then you can use it. So what we want to do, we want to see how we are able to create our own functions. That's the task that we want to do in our tonight class. So let me go back to my board and see how we are able to create a function pretty similar to if, loop, and etc. It needs to have a syntax. Let me go back to my board and have a chat about the syntax on how to create a loop. And then we will be back here in Google Colab and we create some functions. So using functions also, you need it for your assessment task too. When you are creating the password manager, you need to use functions as well. Let's see, go back to my board. And I can see that you put something in the chat. Let's see. PD, pandas. So instead of putting the full name, panda, you say PD. So instead of calling pandas every time, you just say PD. Import pandas as PD. It means instead of calling you the full name, for example, imagine in your home, you may have a nickname. For example, for your partner or your for wife, instead of calling them with the full name, you just use the nickname. So import pandas as PD. It means that each time when I want to use it, I just use PD instead of the whole name. Wait, we have to read a million lines of code just to get a graph. Yes, correct, Mac, completely true. Some things, yes, it's some things that you choose, but there is a standard. So now when you say pandas, all the experts using Python, they say pandas as PD, but yeah, you can say pandas as any other name that it's easier for you to remember and recall. So it's all up to you. You can say import pandas as any other name. Jack, Alex, any name. So it's just designed for simplicity and convenience. Not a problem. Cool. So when you want to create a function, there should be a couple of simple but important syntax that we need to follow. Firstly, when you want to create a function, you need to use def, standing for defining a function. Def. So it's the keyword. Then you have parentheses. So you can give it a name. And obviously you need to have colon. Def means define a function. For example, I can say define even odd. So that's a bunch of code. Then it can goes and check if a number is even or if a number is odd. So then you need to have parentheses and colon. Then you say in this function, go and perform these things. For example, firstly, go and check if a given number, like x reminder by 2, so we already work with that example, is 0. If the reminder is 0, then print even. And if the reminder is not 0, print odd. What happens here? Firstly, you see that I have one indentation here, pretty similar to if and loops. You see that both if and else, they started from the same point. Again, here there is another indentation for if. Again, both print they started from the same spot. What happens here? When I create this function and I name it even, odd. So later on, if I want to retest a number is positive or if a number is even or odd, the only things that I need to do, I need to say even, odd, parentheses open, parentheses close. That's it. Inside this function, we have this bunch of code. It's only 4 lines, but in reality, it might be 100 lines of codes. So imagine instead of 4 lines, I have 1400 lines of code, and I name it like even, odd. And later on in your code, whenever you want to use it, you just need to type this. You don't need to copy paste all of those lines again and again. So it's so handy. Firstly, you need to pay attention that you need to put this colon here. You need to put diff to define. It needs to have a function name. It's very important, the function name. Sometimes you may have some values inside these parentheses. Sometimes not. We will see all of them. If inside parentheses you may have a data, we name it argument. Some functions, they need to have an input to work. Some functions, they don't need it. You just need to give it a name, and anytime that you wish to call that function, you just type it like this, even, odd. This process is calling a function. You just need to type the name of the function, parentheses open, parentheses close, press enter, and then it automatically goes and perform anything that you defined for that function. Let's just see how it works. Let's go back to Google Colab and work with some example to make it more understandable. Green. Screen 2. So def, you see that it automatically changes the color to blue. It means that it's a reserved keyboard. Imagine I want to create a function. I name it hello, parentheses open, parentheses close, colon. When I press enter, it automatically goes to the next line and it types print hello, print something else like how are you today? Anything that you wish to have in this function, you can add it. Now I have 2 lines of code, print, I hope that you are doing well, anything. So 3 lines of codes here. Next time, when you want to use hello, you just need to type hello, parentheses open, parentheses close. So I may have this line of code in another block, save it here. Imagine it's somewhere in the code, but here I have hello, parentheses open, parentheses close. Imagine that your code is 100 lines of code and you save this data somewhere. You gave it a name like hello, calculator, converter, auditor, anything. Anywhere in your code, when you use that auditor, when you use that editor, when you use that converter, you just need to call it like this, put the name, parentheses open, parentheses close, and then you have access to that line of code. Here, if I run it, you see, hello, how are you? And I hope that you are doing well. What happens if you don't call it? Nothing. So you say, look, I have this function, I name it hello, and it has 3 lines of code. You need to call. How? Just type hello, parentheses open, parentheses close, and when you run it, you see that it works for you. So what I do, I go to a couple of our previous examples. For example, a discount calculator. Or let's see if there is any authentication check. So I copy this. So I define a new function. I name it credential check, parentheses, colon, and happens one more time. Def credential check. And all of these lines, there should be one space indented. Encryption, I don't need it. That's the syntax. And anytime you need to check the credentials, you just need to call it. How? You just need to type credential check, parentheses open, parentheses close. Again, in this example, there are only 4, 5, 10 lines of code, so probably it doesn't work to create a function. But when the code is getting bigger and bigger, and then you need to refer to the same bunch of code again and again, you see that it's so useful. Let's still find some other example. Uh, Let me find some example to work with functions. It's like secret coding. There is no indent in print. Yes, it needs to have an indent. Yes. So it's like secret coding. Yeah, pretty. Let's do work with a basic example. Imagine I create this function, diff greet, and I say, when I call greet, print this sentence for me. Print, hello, welcome to Python. Okay, so this is a function. It doesn't have any argument, and it has only one line inside this function. So when I call great, print this sentence for it. So let's see if I type read and I run it. It says, hello, welcome to Python. So that's the outcome. Sometimes you can have an argument for your function like this. Def greet, let's just say user to make it different with the previous example. Greet user. And I put an argument here. Argument is any input that you can give to your function. Let's see how it works. Def greet user, print hello name, and you say that greet user Maxwell. What happens here? So you have a function. In your function, you say each time that I call this function, greet user, firstly, print hello, and then ask for a name. I give you the name. Let's see how it works. Hello, Maxwell. If you go and change Maxwell to John, it says hello, John. If you go and change John to Connor, it says hello, Connor. At this stage, we are manually entering the arguments. But later on, when we see and when we learn about file handling, you see that we are able to create a function. And instead of manually typing data or manually inserting data into your functions, it's able to go and read it from another resource. So handy. So you just need to change the name. Imagine here, instead of hello, I want to send an email to 10 million customers in NAB Bank and say, look, we know that now phishing attacks are very common. So if you see something like this or that, please forward those emails to our phishing security or phishing protections at NAB, something like that. So you have an email, instead of just saying hello, you have a template of an email. The only things that you need to do just to change the name or change the email of the recipient. For example, here, I can create a functions instead of greeting. Let's do it this way. Def phishing email alert. So you create a function. Instead of name, you have email. Then print your email, whatever it is. So you just put the email here. Hello, dear customers, blah, 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 blah. You want to send an email to ATO clients. You want to send an email to Centrelink, you customers. You want to send, I don't know, you want to send an email to all students. It's advertisements or whatever. So you just need to put your email here and email, and that's it. Then you need to call phishing email alert like this. It's an example. So here I manually enter james.k.polk examples, blah, 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 blah. Instead of manually entering this data, it can go and read the data from a TXT file or from a CSV file. And also you can repeat it. You can create a loop. Just go and read the first record, send the email, go to the second one, send the email, go to the third one, send the email, go to the fourth one. So in each iteration, it changed this email. It's sent to James, then it goes to Alex, then it goes to Sarah, then it goes to Natalie, then it goes. So just with 4 or 5 lines of code and having your audience emails and creating the function, it performs the task for you, sending 500, 1500, 1 million emails. You just need to have a database of your customers, import it as a CSV file into Python, create a function like this, and then writing down your email, it automatically goes and you just set it up to start sending emails from midnight. So it's a type of automation. It goes and read the first record, send the email. The second one, send the email. The third one, send the email. Okay, so what else? Here in this example, you see there are only one argument, but it might be more than one argument, like this. You remember that we had an activity calculating the area of a rectangle. Let's find that. Here, area of a rectangular. So it was asking for the length, for the width. Then we have this formula, multiply length by width for perimeter. That's the formula, and then print something. Okay, imagine instead of manually entering this data, now I create a function for it. So let's just see how to do that. Rectangle area calculate. So firstly, you need to define a function. So in order to do that, you type def to define the function. Calculate area. Then you say that when you want to perform these functions, ask for two inputs. Obviously, when you want to calculate a rectangular area, you need to have length. And in this case, we have two inputs. In the previous case, I had one input, which was only email. The rest was an string. So length and width. So you say that these functions needs two input. And then I will talk about return as well to see what is return. Return length times width. Okay. Let's run the code to see what happens. Here it says that you forgot to put the colon here. I know. So it shows nothing because you didn't ask to show anything. Instead, we can add something like this to print the result. Print the calculate area for 10 and 20. It means that the length is 10 and the width is 20. Let's say, what happens if I run the code? You see that it shows 200. And it's correct because 10 times 20, it's 200. So it's automatically calculate the length. What happens if instead of two number, I only insert one number? Calculate the area. I didn't give it intentionally. What is the width? I just say the length is 10. It says incomplete input. So you see this example a lot when you want to create an account in a website. It asks you to go and fill all the sections, your name, your last name, all the necessary fields, it should be filled. So just like a function which is pushing you to make sure that all the sections are completed. For example, if you miss to put down your mobile phone or if it's not in a right format, it says, oh, your form is not still complete, go and fill it. Why? Because it's expect to have 10 inputs. In this case, it's expect to have 2 inputs. What happens if you give it more than 2? Again, it gives you an error. It says, look, I don't understand you because I'm expecting to have only 2 inputs for these functions to work. I need to know the length, I need to know the width, and then what should I do? I print calculate area, I ask for 2 number, 10 and 20, and then this time it works. What it says incomplete. Why? Because I need to put another parenthesis here. Okay, you see that it works. Let's give you one activity. So technically you can go back to each of the previous tasks and change it to a function. Let's find another example. This one, currency conversion. I copy and I create a new function. I put all of those previous codes here. This time I say def currency conversion and colon, and all of these things, all of these lines, I send it one tab to the right because they should be indented. So define currency conversion. This is the lines of code. Anywhere in your code, if you need it, you just need to go and type the name of your function. What is it? Currency conversion, and it starts with capital C. So I type currency conversion. That's the only things that you need to have. Anywhere in your code, if you need this currency conversion, you don't need to come here and again copy, paste all of your codes. You just need to call it. Let's see. Enter the amount in IUD, 560. Do you want to convert it to Euro, Eon, or USD? I want to convert it to USD. And it says 560. It equals to 364. So take your time. You can technically change and convert any of the previous codes to a function. You can go up, find another example like temperature converter. So I copy this and then I create another function. Sorry. Not only that, imagine you write that code, you can share it to others. This is your code, so you change it to a function, def temperature converter, parentheses open, parentheses close, colon, and then all of your codes, send it one tab to the right. So this is your code. You can share it. For example, you have this function, you can send it to your friends, you can send it to anyone else. And if they want to convert the temperature, they don't need to go and write all of those lines again. They simply call that function and it's ready for them. It's ready to convert all the temperatures. So all of those examples that I show you, like NumPy, Pandas, Matplotlib, they may have million lines of codes. It's already created. It's named under a name of like a function. You can go and import it, and then you can use it in your Python for NumPy again. It's already created. It may contains million lines of codes. The only things that you need to do, just to import it to your Google Colab, just to import it here and use it. So it's out of the content of set 3, but I just wanted to show you in case you want to know how to convert, how to import those libraries and use it later. For example, for NumPy, you can type import NumPy as NP. It automatically suggests to import it as NP. So it has millions of lines of codes. You can use it for what type of purposes? You can use it for complex mathematical operations. It's able to work with arrays for scientific computing, for large data sets, network logs, packet captures, all of those things. You just need to import it and then it's ready for your use. Otherwise, if you don't have NumPy and you just want to use Python, Python is like a basic calculator. It's just like your phone. So if you go and download and install WhatsApp, if you download and install NapBank, fitness applications, any other applications that you use on your phone, if you don't have those applications saved, so obviously you're not able to use the best of your phone. When you import and use those libraries or functions, then it improves. Anyway, the last thing for today. Yes, the last thing that I want to explain today, let me to stop this.